if we look at the last 10 years of free response questions, in terms of the BC topics that are asked, we know that the 70% of the material in this class is like AB material and 30% is BC, but then the test ends up being 60% AB questions, 40% BC questions. Okay, we needed to do your AB subscore. We're going to do that next class. Over the past 6 years, 7 years, there are very strong consistencies that you can see. There will always be a question number 2 or number 6. They sometimes change it up just to, throw curveballs at you. Maybe this year they'll do it. No, they haven't done it recently. And number 2 is either a parametric or a polar. You're hoping parametric, but they threw 2 polars in a row in 2013 and 2014. Okay? The rest of the years were all parametric. Okay? That's number 2. That's all BC material. That's just an only BC question. And then number 6, every single year, is your Taylor free response problem. Okay? Typically, you got to do the ratio test, you find the interval of convergence, check your endpoints, you write out things, maybe you do some manipulations of them, and there's an error problem in there. Okay? You just got to be comfortable with this. Now, there's a third question that is half AB and half BC. Okay? And this is a BC only question. However, it's not all BC material. And this is where they throw in some different things here. You see Euler's method shows up, but it's just like one part of the question. The rest of the question is AB material. Partial fraction showed up, arc length showed up, L'Hopital's have showed up. Okay, but really it's parametrics and it's McClure and Taylor. That's what we have to focus on for free response from BC. Cool? Now, the AB, oh, did I not copy that? Okay. Now, what happens is that you guys will share 3 questions with the AB test takers. Okay? Like question number 1 last year was a question that the AB students and the BC students all had to complete. Okay? And so 3 are always shared. But if you look at the last 5 or 6 so years, they always eliminate certain ones and they always keep certain ones. So for the BC test, it's actually easier than the AB test because it's like, man, we got a parametric / polar, we got a Taylor, and then we go back to the AB material and it looks like we'll have a rate problem. So you're given a rate and you're asked to find totals by using integrals, initial conditions. You'll have a function analysis problem, which is your derivatives, graphs of derivatives, finding locations of maxes and mins, finding absolute maxes and mins, stuff like that. Maybe the accumulation functions in there. You will have a table problem. Table problem is usually they give you a table of values. They ask you to calculate some things and explain the meaning of those calculations, where it's the average, maybe we have a velocity and you're finding, an approximation for the derivative. And then usually the shared problem is a differential equation where they will throw in a BC material. So usually the differential equation will use Euler's method as their BC part to get up to that 60% instead of 3 questions and 3 questions, that'd be 50-50. So they scale it so that it's a little bit more AB. So it's like 3.5 questions are AB and then 2.5 are BC. They do some area of volume problems, either parts or the entire problem. So if you think about it, parametric polar, Taylor, rate, function analysis, table, other. Okay? Very specific types of problems. You might think that, anything can be asked, but actually it's not anything. Okay? We will be splitting this up into sections. And I'm wanting your opinion on the order of the sections. Right now, I have it split up so that we are doing AB material, and then I have a day for parametric polar, and then I have a day for Taylor-Maclaurin. So it's like 50-50 time. I'm wondering, do you want to do the BC material first, the parametric polar and the Taylor, and then the AB second, because we're not going to have a review day. We're going to just take the test after the weekend. Or do you feel comfortable with parametric polar, so we combine these and I spread out the AB topics a little bit more? Discuss with your neighbors what you think you would like to do, or if you're probably just okay with this. Go. I could spread out the AB material and shrink these into one day. So it's just like, here's our BC day. These are our homework problems, you know. We will have a quiz on, we will practice and then have a quiz on whatever we start with here. And we'll quiz over that here. And then this will be your homework and we'll quiz over that here. But we will practice, then quiz. You know, we'll do like 2 problems, 3 problems, and then we'll take a quiz. Okay? And you'll be able to see how the free response problems are graded when we grade the quizzes. Yeah, I can do anything, really. But the key is to chunk them into types of problems rather than go year at a time. If you go year at a time, you don't feel that things are the same every year. But if we say, look, rates/function analysis, 2016 1 and 3, 2015 1 and 5, 2014 1 and 4, 2012 number 3, 2011 2, 2010 1, 2009 2. It's all the same stuff every single year. It's repetitive. Ideas. What do we think? Is this okay? Or do you want Taylor first so that we quiz over Taylor? Because it would be good practice. If we don't have Taylor, well then we'll just, if we don't have Taylor to the end, well then we'll just take the test and you're gonna have a Taylor problem on that and you'll get the grade. Would you like to quiz, which one do you feel least comfortable with? The BC material, right? So that means we'd like to practice the BC material in class, right? Right? So do we want to then do a nice easy one right now and then do the harder one Monday? Or do we want to come right off the bat, get into the most recent unit? You had all these free response problems. You just get to try them again. You already had the packet, but now you just get to try them again. And then we come back, we practice those Taylor Maclaurens, and we take a quiz on that. Or do we want to do parametric polar? Definitely not BC first, because that's today. Right, well, we're not really doing much today. We were going to talk about rates if we were going to do rates today. But we are going to show up next class. You'll have your homework done, and we will practice and then quiz. All right, think about it for a second, and then I'm going to put a poll up. You can just raise your hands. We'll do 7 up, heads down, thumbs up. If we're okay with this, that's an option. Second option, do BC material first, parametric polars first. Not that difficult, except for the polars. Third option, do BC material first, start with Taylor Maclauren. Okay, think about that for a second, and then I'll take a vote. What if we just switch Taylor Maclauren with Taylor? Okay, that's fine. We could move this here. That way we practice and quiz that on Friday. And then parametric polar, if you're comfortable with, it is kind of easy, in my opinion. And we have done it recently. Typically, arc length for parametric, velocity vectors, and then application of the fundamental theorem of calculus. You're given velocity vectors, and you're asked for a position. So it's like x of 5 is equal to x of 0 plus your integral of your x component of your velocity. That gives you your x position, and then you do it with your y position. I like that. Are we cool with that? Okay. So we'll start with our AB material. It is the stuff that has been, you know, hasn't been around us in a while. And then we'll switch to BC material, but the harder BC material, and then you'll be on your own to go over parametrics and polars. And then we have our practice test. Then we have 2 days. On this day, we'll go over the free response test, and if people want to retake a multiple choice test, they can do that on this day. This day, same thing. We'll get back our free response tests and our practice tests, and we'll just go over it. And if we'd like to do anything else that day, we could do that. What's up? We got a taper. I know. We're not going to do another practice test. You can do a practice test here. I'd advise that. No harm. But then this will just be, here's your stuff. Do whatever you want to do. All right. All right, well, let's talk about rates really quickly before you guys leave. Very important. Rate problems have become more and more popular. Topic sets are now consistently being asked on the BC test. Question number 1 over the last 4 years has been a rate problem. And they trip up students. Let's look at 2016, look at 2015, number 1, really quick. Okay, we read this question, the rate at which, and we had a whole unit where we dealt with rates. There's a lesson that we can look at. But we read this question, we say the rate at which rainwater flows into a drain pipe is modeled by R. The pipe is partially blocked to allow watering to drain out the other end of the pipe at a rate modeled by that, D. There are 30 cubic feet of water in pipe, at time t equals 0. Part A is how many cubic feet of rainwater flow into the pipe during the 8-hour time interval. The most common mistake made is that students assume, okay, this is water entering, so I just find R of 8. Which is 20 sine of 64 over 35. Okay? This is wrong. Okay? Very, very wrong. The reason why it's very, very wrong is because what you are given is a rate. Okay? Think of a rate as a derivative. It is how much things are changing. It is how quickly rainwater is flowing into the pipe at a specific moment in time. It is not a total amount. D is also a rate. When we go through free response problems or multiple choice problems and we see this word rate, we need to think that's a derivative. Okay? This is a derivative. Even though they're using capital R and capital D, they do that on purpose just to try to trick you. Okay? It is a derivative of a total. Now, what do I do with a derivative to get the total? How would I get the actual total water that has flowed into the pipe? An integral, right? Integrals of derivatives will give me, the original function. In this case, the integral of the rate at which the water is being flowed would give me the total water that has flowed into. Now, the problem is, if I try to take the integral of this, I can't take the antiderivative of it. It's just 20 sine of t squared over 35. You don't know how to handle that. Plus, there would be a plus c, and then all of a sudden that makes things complicated. But what you can do is do a definite integral. And if I do an integral from 0 to 8 of r of t, this would be the change in the antiderivative of r, which would be the change in the total amount of water that has flowed in. Does that make sense? Take integrals of rates and you'll get totals. But things get more complicated if I ask you, well, how much water is in the pipe at the 8th hour? What if I asked you, how much water is in the pipe right at T equals 8? What do you have to consider now? What's that, Mr. Romany? I have to consider that water's flowing out as well as flowing in. What else do I have to consider? The starting value. How much water started in the pipe? Well, all of a sudden, we will have something where we said, okay, I started with 30, but then I had water coming in, and then I will subtract the water going out. And that's how you can find your total. Okay? All three things are important for this. Now, I actually can change this up a little bit, and I could write it like this. 30 plus integral from 0 to 8 of r minus d. Right? What is this? This is the whole application of the fundamental theorem of calculus, where if I want to find a total amount at a specific time, I've created a new function, t. Okay? Why? Because they gave me a capital R, so I can't, say it's r prime and then this will be r. I just created a new function. I say this is my function for total. And we've done this in the past. Okay? And we know that that's equal to my initial amount plus the derivative, the change in the derivative, change in the function, which is the area under the derivative. So integral of t prime. Well, think about this. If t is the total amount, t prime would be the rate at which water is going in minus the rate at which water is going out. This will tell you if water is decreasing or increasing, if this is positive or water is increasing, if this is negative or water is decreasing. Okay? So for all these rate problems, it's very, very crucial. I'm just going to leave it at this, that when you're given a rate, you take an integral to take a total. And don't forget our favorite formula that is used more often on the AP exam than any other formula, that a unknown is equal to a known plus the change in the function, which is the area under the derivative. And I did this in class with you guys, like to use t for a total amount at time b. Typically, you're given an initial amount at time 0, and we'll go from 0 to b of t prime, where t prime equals my rate in minus my rate out. Okay? That's your problems. Your 5 cents for your function analysis problems comes from a video that's online. It's just reminding you how to justify finding maxes and mins. You find a max when the derivative changes sign from positive to negative. You don't need to write much with our justifications. I'll go over when we practice next class, just how you just need one simple statement. And if you write your simple statement, you show that the AP readers you know what you're talking about. Okay? We are doing great. You guys are doing great. Keep it up. Don't slack off now. It's a shift of gears. We're shifting to free response. But believe me when I say my students outperform their peers on free response relative to the multiple choice. This is where you make a big difference in your scores. Okay? Most students do better on free response than multiple choice. All right. Thanks. We'll see you guys on Monday.